Good morning, student. Laboratory of the switchgear and protection. In last lecture, we have to seen in the maximum current type fault protections, inverse time delay fault protection. Already 2 to 3 different protection over current protection we have to seen about it. Now we have to see the instantaneous over current relay. In this instantaneous over current relay, the relay is operate when there the pickup current is accumulated by the our set currents. If you are the pickup current is a 10 ampere, just an example, our the fault current is a 10 ampere. Our value is the 15 ampere. They will the relay is not operate, but our the fault current is extend the 15 ampere. Then we relay is instantaneous operate. They will be not wait for the any kind of the confirmation like a time delay or inverse time. If you are the current what current gradually rise or decay, is not matter, but there will be open when the our current is the extend the 15 ampere. First of all, you have to see the example of the this type of this is a three-phase source, the three-phase circuit breaker. We are measurement in terms of the power system. We have to see this is CT and PT, current transformer and potential transfer. But in MATLAB Simulink, we have to use this VI measurement. Okay, so VI measurement, there's a VABC. It's a one line they will be given to the, this is a bus bar line, and also be they will be give the IABC. Matlab, there's a I current I is equal to A or BC. They will be given, and the three-phase load are there here. This is the RLC load. In terms of the, we have to see the RLC load is a inductive capacity or reactive load. So we have to set the RLC load is the active power is 5 kilowatts, reactive power is a 10, or the or capacity power is a 10, and frequency is 50, nominal power voltage is a 450. And this is a fault, three-phase fault we have to create. In this three-phase fault, we have to create phase A, B, or C. In three phase we have to create fault. If you are the one to create the only phase A or B, the fault resistance 0.0, and we have to give the command from this timer. The timer is operated at the 0.1 second and amplitude is 1. If you are amplitude 1, we have to give into the three-phase fault. The fault is operated. Now we have to come to this relay operations. The relay sends this current IABC. Here to they will be give to the IABC input. After that, we have to demux this bus bar. We have to demux this bus bar. So three different current I, A, or B. In terms of R, Y, B, we have to give it. So we have to create the three different relays for the IA, IB, or ICA. So this is our reference voltage, 10 voltage. We have to set the reference voltage. In the relay, first of all, we have to create their absolute value. Because of the all the waveform are time to time change, we have to find the absolute value. Now we have to compare with this the reference voltage. If you are the compare, they will be give to the high, and if you are the our D latch in the D flip flop, and the QI is given to the high. If you are the all the relay are given to the high, the end logical operation is the give high. Or we have to here change the OR operation. If you are the any of the one phase, if you are consider any of the one phase are get faulty, their relay is operate. If you are we have to get in the end operation, they are the any of the one phase is not faulty, they will be not operate. In just we have to see this is OR operation. Now we have to simulate this. We have to send in a scope result on scope. Here you can do yes, see the only A phase or C phase we have to create the fault. So A phase or C phase fault are there, and the another here in the second graph you have to see the voltage of the another phase. Because of the all this voltage is appears due to the mutual induction, and this B phase is the healthy, and the B phase current is only. Now we have to create the fault at the all the three phases. Now another we have to simulate. So you can see when the point at the 0.1 second, then the relay is instantaneously open. The current and this voltages appear due to the energy storage in the storage equipment like inductor or capacitors, but there will be relay is operated and circuit breaker will be operated. Now we have to see in the this relay operation. Just here we have to see the or operation. Now we have to see the end operation. Now we end operation. The all three phases operation or fault are done. The relay is operated when we have to use the end operations. Just you can see the graph is similar. We have to see in a graph is similar. Just we have to see in a previous. Now we have to change. Remove the any one fault like a B fault. We have to remove. The relay is not work properly. Yes, you have to see the when the relay what the relay operation because of the all the phases are zero. You can see in that when the we have to see the end operation or for the any of the one current or one of phase are not faulty. So this is the all about the instantaneous work and relay. Next next laboratory we have to see the what is kind of the differential protection, zone of protection we have to see. This laboratory based on the three-phase overcurrent relay, instantaneous overcurrent relay. Thank you for your attention. If you have any doubt, you can ask Phil in the email or WhatsApp chat. It's your wish. Thank you for it.